Hey, it's John at Tinderbox Arts. I'm finally getting to a project today on my BMW R1200RT that I've been intending to do for some time, and that is to install a fan on my oil cooler. Now, this is an older model RT. It's a 2012 model, and a lot of the older ones were oil cooled. There is some air cooling, of course, from the heads, but the main cooling came from right in here. So there's an oil cooler right here, and it's just fed by air from the road. There's no fan behind it stock. Now, newer models of RT are liquid cooled, and the reason most manufacturers went with liquid cooling in more recent years is because the emission standards have changed, and because of that they needed to run the engines a lot leaner, sometimes with higher compression ratios, and they just run hotter. So it got to the point where they could no longer cool the engine reliably with oil coolers, so they went with liquid cooling. The oil-cooled bikes are generally okay as they're designed, but there are instances where the oil cooling is just not enough and it can lead to overheating. Now, my friends in the UK often argue this fact, and they say, you know, if you're in a bad situation, just pull over and let the bike cool off and you'll be fine. Well, here in the US, things are a little bit different. You know, the highways are huge, and the amount of traffic on those highways is unbelievable. And there's been 3 instances that I've been in with this RT where I started to get dangerously overheated, and there's nowhere to pull off. In one instance last year, I was on a approach to a toll booth, and it was probably 8 to 10 lanes wide, okay? We were completely surrounded by trucks, and the ambient temperature was 102 degrees. So it was extreme conditions, and we were breaking down ourselves without enough water. But the bikes did start to overheat. I did get through the toll plaza, but it was stop and go traffic, mostly stop. And there was just nowhere to pull over. There's trucks all around us. We were in communication constantly, just trying to stay safe. And that kept up for quite some period of time. The bike got quite warm. Eventually, it did clear up, and the traffic, you know, sped up a little bit, and I got some airflow, and I was all right. But it was a close call. And that was the last time. I've had 2 previous instances. Both of them, actually, one was on a highway where I just couldn't pull over. It was stop and go traffic. The next exit was 10 miles away. And another time we were visiting an air show on local roads, but we had tens of thousands of people visiting this air show, and it was, again, stop and go traffic, nowhere to pull over, and it got a little dangerous. So because of these instances, I decided I really needed to install a fan, and this would go behind the oil cooler so that I have the option, if I'm in stop and go traffic or something's going wrong, to turn this fan on, get some airflow over that oil cooler, and that will bring the bike down into a range where it should be. Now, here's the backstory on this particular bike, the RT. It did not come with an oil cooler fan stock if you had the civilian model, but the RT is used on a lot of police bikes, and because of that, BMW did design a fan to go behind the oil cooler for obvious reasons. Police bikes are often used in situations where they'll be idling for long periods of time, and you're going to need some kind of fan to cool it. So this particular fan that you're looking at right here is from a police bike. I did not think I was going to be able to get this. I intended to just get a generic fan and fit that fan to the bike in whatever way I could, but I just got some dumb luck, and I found this on eBay, picked it up. It does seem to work, so I am going to install this. However, I want to stress that you do not need to get this, official fan from BMW or, from eBay or something like that. You can fit a generic fan. I just happen to get lucky to get this one. But because I do have it, in this video, I'm going to give you the dimensions of how it's mounted, and we're going to look at the electrical requirements. So at least if you can't get the official fan, you'll know what the official fan looks like and what kind of requirements it has. So believe it or not, this fan is going to fit behind this oil cooler, but to get it in there and to do the electrical, I do need to remove the fairing. So I'm going to do that off camera, and then we'll show you better where this is going to go. All right, before we get to the electrical part of this installation, let's talk about the physical part. I am going to give you measurements of this, so if you're making your own out of generic parts, you'll be able to use those measurements. But before I do that, let me just show you how this is going to mount. Right here's the oil cooler. I took this little nose thing off just to give me some more reach in there. If I bring the camera around, you'll see at the back of that oil cooler, there's a mounting tab right here where my finger's pointing, and there's an identical one on the opposite side, which I will point to right here, okay? So those two mounting tabs are going to need some kind of bolt arrangement. And then there's a little recess right down here. There's a little recess where there's a plastic tab on the fan, and that goes in there. If I look down at the fan, you'll see I got a mounting bolt here, and that little plastic tab right here goes into that recess. Now, if you're making your own parts, I really don't think you need to worry about that recess so much. It's more these mounting tabs that are important. So you want those dimensions. And even though this stock fan has kind of a shroud around it, which I'm sure does increase efficiency, I don't think it's strictly necessary if you're using generic parts. I think you can use just a fan that you find of the appropriate size and then just go with that. Now, if I look at the opposite side, that tab is right here where my finger's pointing. And you can see there's some other things sort of in the way. There is enough space to put a bolt in there, but it's just a little tricky getting your fingers in there to mount it. All right, if I measure the physical dimensions of this fan, the fan blades themselves, it's a 5-inch fan, okay? And if I measure from the center of this hole to the center of this mounting hole, it's difficult to measure because you kind of got to look down rather than put the tape right on the hole, but it looks to be about 11 3/32 of an inch, which I think is about 281 millimeters, or in that range anyway. So these holes are fairly big, so if you were a little bit off, you could just use a little bit smaller bolt, but that's the general dimensions. The back side of the fan looks like this. These mounting bolts are not symmetrical. And here's a close-up of the tag on the fan. I have not decoded that, other than I can see it's 12 volts, but maybe somebody else can do that. And the fan does slip easily up under there. I can just slide it up in like that. I have to fiddle with it a little bit, but it will go in there without too much trouble. So the physical mounting is not really an issue, but the electrical part of it is something I want to tackle next. Now, in a previous video, I showed how I installed this hex CAN device, which integrates into the bike's CAN bus electrical system and allows you 4 new circuits, and those circuits can be controlled by the existing bike controls, which is nice, and that's a main reason why I installed it. Now, if you don't have something like this, your other option is to put a fuse block on the battery and wire a switch so that you're basically creating a secondary or parallel electrical system for this fan. Either one will work, but in that case, you'd have to have a place to mount that switch somewhere up by the dash, and that was annoying to me, so I was willing to spend the money on this. So for the electrical connections, I'm going to use this weather pack style connector, which I have another video on how to use these. The fan had a wire attached to it already, so I'll just reuse those and connect them to this one side of this connector. Then I'll use 16 gauge wire to get back to that Hex EasyCAN device. And the Hex EasyCAN device came with these pigtails, which I'll use. So it has their connector on one side, and on the bare wire side, I'll just solder those to make them permanent. Okay, I got the fan mounted. This is the left side. You see I used a aircraft nut or a nylon lock nut. On the right side, there's a little Delphi electronic unit here that you can move out of the way by loosening 3 bolts underneath. And then you can see the nut right here where my finger's pointing right now. It's a little tough, but you can get in there. The only thing I'm not thrilled about is that the fan shroud is almost touching the oil cooler itself, which hopefully that won't rub. But this is stock. This is the way it was done originally, so I guess it's going to be okay. All right, I got the new cable connected there. It goes under the gas tank following the factory harness there. This is my new harness right here. I go along the frame and it reaches in the back here. And I have extra so that I can now connect it to this Hex EasyCAN. All right, I have the Hex EasyCAN software running, and this laptop is connected to that device. I have all the circuits disabled except one, the blue one. It just happens to be the one I plugged into. And that is configured as an aux1 circuit. I have all the, because this could be used for lights too, so I have all the things that are related to lights turned off. And really we're just concerned about having a voltage or not having a voltage. So the way the controls are going to work with this aux1 circuit, it's all with the info button. So what I'm going to do is I'm going to hold this info button down continuously for 7 seconds. At the end of 7 seconds, I'm not sure if you'll hear this on camera, but there'll be a little buzz. It'll go bump, bump. And when it does that, it's telling me that it's ready to receive input. At that point, I can start pressing this info button. Each time I press it, it will increase the voltage. I think it's 9 or 10 times until I get to the full 12 volts. And then the fan will just stay on. Now, when I want to turn the fan off, again, I will just hold this button down for 7 seconds and the fan will turn off. So I'm not sure how much will come out on camera, but I'll show you how it works. I'm going to hold this down. There's the buzz. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so each time I press that button, it's increasing the voltage, and the fan speed increases too, of course. So now that's running at full voltage. I could just leave that on. Now when I'm ready to turn this off, I'll just hold this button down continuously for 7 seconds and the fan will go off. And that's turning the fan off. When I run that fan off the battery, I'm getting 3.8 or 3.9 amps. So I'm going to call it 4 amps. On the HexCAN diagnostic screen, that's getting 3.6 or 3.7 amps, so pretty similar. Now one last thing, currently the fuse for that circuit is set to 10 amps. I might bring that down maybe to 7.5 amps. There's no reason to have it up that high. But other than that, the software seems to work, the controls seem to work, and I think I have my fan running now.